PN junction diode, we are going to get PN junction by sandwiching a P layer with a N layer. Between this, a junction is going to be created. That's why the name PN junction. Only this part is the PN junction. So this part is the PN junction. To this, we are going to add some metallic threads or copper threads. These are the two threads. So when you add these two threads, then it becomes a diode. So why we add this threads is to make it easier to connect it to the components. So what is P layer? P layer is the layer which is having majority charge carriers as majority charge carriers as holes and minority charge carriers as electrons. In N layer, we have majority charge carriers as electrons and minority charge carriers as holes. So when you discuss about the electrons and holes, yesterday we were discussing about the word carrier. What is a carrier? So a charge, difference between the charge and a carrier. See, let us assume, I'll just give you an example. We have a vehicle, and this is a warehouse, and this is the destination. The vehicle is going to load, the vehicle is going to take up the load, or the load is getting loaded into this particular vehicle, and that vehicle is going to this destination. It is going to deliver the goods, whatever it is loaded, and it will come back to the warehouse. Okay, here there are two things. One is vehicle and other one is the goods which it carried. So goods is the charge and vehicle is the carrier, right? So here the electrons and holes are the charge carriers. They are the charge carriers. So we need some carrier to transfer the charge from the supply, and it has to be delivered. So basically, in general sense, what is a charge? It is a form of energy to do which is going to be used to do some task in electronic devices. So that energy has to be brought from the battery. So battery, it is having chemical energy. So that chemical energy is getting converted to electrical energy. So that chemical energy is going to fill up the energy to these carriers in the form of charges, and that is going to reach this particular particular destination and come back. Here also in the same way, we have P layer and N layer. I told you there are holes are the majority charge carriers and electrons are the minority charge carriers. One thing, electrons and holes. So to this, you should understand perfectly what is electrons and holes before going on to the actual topic. So for this, I'll give an example. We are in the class, okay? So you're all in the desk, sitting on the desk. I'm standing here. So let us take there are different students who are sat in the class. I'm telling this particular person to go and sit at this place. Okay, at this place. he can go and sit at this place only when the seat is vacant, right? I cannot, if the seat is occupied, the he cannot go and sit there, right? So here seat is vacant, so I can force him to go to him to go and sit at the particular location. But at the same time, now what happened? This seat became vacant and this seat became occupied. Now again, I can call this person to come and sit here, because here the seat is vacant, he can come, but I cannot call this person to come and sit here because the seat is occupied already. So from this, let us analyze this as this is a semiconductor. You're all electrons. Students are all electrons. Holes are all the desk seats. So I am the battery because we need to give some external force. From this, what you understood, I'll tell you in detail, but from this, what you analyze. Electrons are the students, desks are the holes, and the force. Which is moving, which is not moving?
Electrons are moving, holes are not moving, sir.
Okay. So, but it appears to be moving, right? Holes are not moving, but it appears to be moving.
Yes, sir.
So that is what we tell electrons have mobility, or we tell they are mobile charge carriers. These are all immobile charge carriers. That means the hole will never move. In the class, the seats are not moving. Electrons are moving. That is, you are moving. You can sit in the front bench. I can make you to sit in the back seat because I am the battery. I'm forcing you to move back. So you are going to move and sit back. So you are moving because of this, because of your movement, the seats appears to be shifted, but actually they are not, seats are not moving. This is what happens inside the PN junction also. The holes will not move. Holes will never move. They are immobile charge carriers. They will never move. Only electron moves. But in order to move the electron inside a semiconductor, we need a vacancy. That vacancy is hole. The electron can move only when there is vacancy. So if there is no vacancy, the electron cannot move. So here in the PN layer, when you are sandwiching the PN layer, here we are all having the holes, we are all having electrons here. See what happens, these holes are positive charges, electrons are negative charges. So when the holes and electrons are very near to this particular junction, they will recombine. That means recombination means this becomes electron, this becomes hole, because when it has shifted to the another hole, the vacancy will be created. That vacancy is a hole. So here what happens, the same way, here we will have electron, here we will get hole, here we will have electron, here we will be having holes. That means shifting of electrons are taking place. But this shifting of electron will not take place to this end, till this end. We need some external supply. We need some external force to shift this. Right? So what we do is we connect, P is known as anode, and the other one is the N is known as, N terminal is known as cathode. This is positive terminal, this is negative terminal. We are going to connect this PN junction diode to this battery, and P to P connection and N to N connection will be done. This type of connection is known as forward biasing of a PN junction diode. There are two types of biasing: forward bias, reverse bias. Forward bias means we connect positive to positive, negative to negative. Reverse bias means we connect in the reverse way. So we will connect in opposite way. See, now this is negative, this is positive. Negative is connected to the positive terminal of the diode, and positive is connected to the negative terminal of the diode. So this is reverse biasing. During forward biasing, the diode is going to conduct, and in reverse biasing, diode is not going to conduct. That's why we call this diodes as unidirectional devices. The current can flow only in one direction, that is in from positive to the negative side, that is P layer to N layer. So this is the conventional direction we are going to consider. Conventionally, it is we take always from positive to negative, but actually electrons will be always flowing in opposite direction, right? Electrons will be always flowing in opposite direction. That's why holes, the charge on the hole is plus q, the charge on the electron is minus q. Electrons are always flowing in opposite direction. Even though we tell the current is flowing like this, but electrons will be flowing in the opposite direction. So this is the schematic symbolic representation of the anode. And along with this, there is some more concepts that needs to be understood. That's need to be understood. So I was telling electrons as negative, holes as positive, right? So now here, when you are talking with respect to the charge, it will be negative, this will be hole. I'll take understand this concept because in the books it will be marked like this with this symbol plus minus. See, if you are having this kind of symbols, it shows they're all ions. They're all ions. Now, when do they become ion, or which charges or which charge carriers you will be calling it as ions? See, when you consider an electron, it is going to leave the location. Leave the location means we call it as the electron is donated. Electron is donated. And in the hole, what is happening in the hole? Here, from this place, this particular place, the electron is donated, and this particular place, the electron is accepted. Right? Electron is given out. On the other end, it is accepted. So the place where the electron is given out, where the electron is given out, that place becomes a positive ion. The place where, or the carrier where the charge is accepted, will become negative ion. Okay, you have two things. One is charge. When you talk about the charge, electrons are negative. When you talk about ions, what it become?
Positive.
Positive ion. Right? Holes, they are negative ion. But when you talk with respect to charge, they are positive charge. Okay? We call them as this as donors, and we call them as acceptors. When you accept, you become negative. When you donate, you become positive. That is what you should understand. Okay, so wherever you have this kind of symbol, you should understand it is ions. That means we have donated one electron, or we have accepted one electron. That you should understand. So coming to this p-n junction diode, all of you understood this basic things?
Yes, sir.
Okay, coming to the p-n junction. Coming to the p-n junction diode, so we have, as I told, these are all holes, these are all electron, minus symbol indicate electrons. You can see that these electrons which are very near to this holes, because positive and negative always attracts, so they get attracted here, and because of that, see here what happens. Compare this to figure, what was hit and what is now. Whatever I thought till now, it has been shown here.
Yes,
I'm
sir.
just asking about these two. These two. Can you anybody tell what has happened here?
Sir, they
Charges
become
are
ions.
converted into ions.
Yeah, charges are getting converted into ions. Why
Ions.
we have minus here?
They
It
are
has
accepting,
donated
accepting,
electrons.
accepting.
Accepting. Negative means accepting. Donating means positive. See
Positive.
this donated. So that becomes positive. Okay, or in another way, if you're getting confused, you can remember like this. See, this was hole which was positive. Now electron came and sat over here, sat over this portion. So it becomes all electron. So it becomes minus. Here a hole is created, so it becomes positive. In either of the way, however you feel comfortable, you can understand. So free electrons are represented by minus dash symbol, and the holes are represented by small circle. So when free electron leaves n side and falls into the hole of p side, two ions are created. One is positive ion and other one is negative ion. So because of this movement, a barrier potential is created. Basically, what is a barrier? I mean, what is potential? Potential means voltage, right? What is voltage? It is the difference in the concentration between the 2 points, two ends, right? Between p layer and n layer, we have this junction which is going to separate p layer and n layer. So there is a separation means, can I, for our understanding, I'll tell you how voltage is created. This junction is separating these two, means, can I assume that this junction is having some resistance? It is separating, that means there is some resistance, right? Opposing
Yes,
to
sir.
flow. If you take a real-time example, a junction means what? We'll have a signal, so that is going to oppose easy flow of the vehicle. So we have to hold on and then we have to move. So there is a restriction, or there is an opposition to the flow. So there is a resistance here, we came to know. So there is a resistance between. So we will be using some material here to sandwich this p and n layer. So there is a resistance. Through this resistance, what is flowing? Through this resistance, what is flowing? What is
Current.
flowing? Electrons are flowing, right? Flow of electron is known as,
Current.
yes,
Electric current.
current, right? When you have current, when you have resistance, what you'll have according to Ohm's law?
Volt.
Voltage, right? So this is how when you connect a battery, I mean, when you are, this is how we are going to assume there is kind of voltage which is produced. So now the question is how I can find out this voltage. How you can find out is, don't connect any supply to this, just use a multimeter. You know about multimeter, right? Multimeter, voltmeter. Multimeter is a device which has voltmeter, ammeter, temperature sensor, capacitor meter, everything in it. It's a multiple measuring device. Instead of telling a voltmeter means it can only measure voltage.
Potential
Ammeter,
difference.
ammeter
Current.
means it can only
Current.
find the current. So multimeter will have all the options there. Okay, so if you are going to connect that multimeter, or let us say we are just connecting a voltmeter here, the voltmeter will be showing a voltage of 0.7 or zero point 0.3 here. See, we are not connected the supply, but still we are having 0.3 or 0.7 volt. How did we get this? We got this because of this charge movement which took place, because of the charge movement which took place across this resistance. So when this current is flowing across this resistance, a potential difference is being created. So finally we will tell that this barrier is going to offer, barrier means a junction which is going to separate two things. It is going to offer some potential. That potential is known as barrier potential. Okay, so then what is the standard value, 0.3 or 0.7? See, it depends upon the kind of semiconductor material you are using. Suppose you are using silicon as a semiconductor material to manufacture PN junction diode. So if you are using silicon, then it is going to show a 0.7 volt barrier voltage when in the voltmeter. So suppose this is a silicon made device, then it will be showing you 0.7 volt. Suppose you are using germanium, then it will be showing you 0.3 volt barrier potential. Okay, so here once the ions are formed, they are going to form the depletion region. You can think, oh, they're jumping. No, they can keep on jumping like this. It cannot happen like that, because when they are going to cross, they become ions. When they become, this area is been occupied by these ions. After that, it cannot further move unless you are going to give some external force. So because of this, what happened? We had a depletion layer of this much, a junction of this much. This depletion layer has become this much because of ionization. So they have got converted into ions, and because of that ions, they are the depletion layer is increased. So now, in order to make the current to flow through this, what I should do? I should connect a battery. That to connect a battery, we have a term called biasing. What is biasing? Connection of external power supply to a device is known as biasing. It might be anything. If you are connecting it, we tell it you are biasing it. So the term bias voltage is defined as the DC voltage applied across the terminals of a PN junction. We have a diode like this. So this is which terminal? This is which terminal?
Positive terminal, sir.
Positive terminal. This is negative terminal. So we are going to connect a battery like this. So the larger line is positive, smaller line is negative. So now we have connected an external power supply. So if you are connecting positive to positive, negative to negative, it is forward bias.
Forward
If you are
bias.
forward bias. If you are doing polarities, you are going to reverse it. Then it is reverse biased. Okay. So current, the diode will conduct only under forward bias condition. It will not conduct in reverse biased condition. So now, first thing is forward bias. Here we have connected the positive terminal, we have taken the supply, power supply, and we have connected the positive to the positive and negative to the negative. So here, when this voltage is this again, as soon as you connect it, it will not start conducting. You should give the voltage across from the power supply. This voltage should be greater than the barrier potential. It should be greater than barrier potential. Why? Now the question is why it should be greater than barrier potential. I had told you that there is a kind of voltage which is been existing here. So can I compare, see this is P layer means, can I compare it with a positive plate? Can I compare it with a positive plate? This is a positive plate. Okay, N layer, I am going to compare it with the negative plate. So what it becomes now? And I'm going to tell it is having 0.7 volt. Can I write like this? Just for analyzing, P type is positive, positive, positive plate. N type is negative plate. In between this, we have a gap, that is our depletion region. Okay, just for understanding, this is a 0.7 volt battery. So which is given out because this is acting like a 0.7 volt battery, and the input whatever we are having, that is the power supply we are having. So here when the power supply, it is connected like this, see how they are now, will they added up or subtracted? Huh? Will they add up, this both of them get added up, the voltages of these two get added up or subtracted? Let us take, I have a battery of 0.5 volt. Hmm? Think on how you'll be putting the shells, I mean battery shells to the torch. How you'll connect?
-1 positive.
Hmm. Negative of one to positive of another, right? See, if this is the shell, one shell, the next one, is it like this? This is positive, negative, positive, negative. That means negative to the positive we are connecting. Why are we not connecting like this?
Charge
Hmm?
will not flow, sir.
Charge will not flow, right? So what will happen now in this case? They will get added up or subtracted. Or see this 0.7, I'm comparing this PN junction to a battery, no? it is also giving some amount of current. This is also giving some amount of current. Now, in this, which current will flow? I'll tell this is I1, this is I2. Which current will actually flow in the circuit?
I1, sir.
I1. Why?
Because it is greater than I2.
Yes, very good. So I1 is going to flow through the circuit, not I2. Why? Because this voltage is dominating this voltage. From this, what we understand is, if you want the current to flow through the diode, then I need to give a voltage which is greater than the barrier voltage. So this is the barrier voltages 0.7 or 0.3. 0.7 for silicon, 0.3 for germanium. Remember this, again and again we'll be using this. So now if you want the current to flow through the circuit, then you need to make the input voltage greater than 0.7. So same thing, I'll make it as 0.8. Now which current will flow?
I2, sir.
I2 will flow because the I2 is dominated over I1, so that will flow. So here also remember the first point what you will be writing is, until the input voltage or the supply is lesser than the barrier voltage, the diode will not conduct. When the input supply becomes greater than the barrier potential, then the diode starts conducting. We show that current flow like this, that is the conventional direction, but actually the electrons will flow in the opposite direction. So conventional direction is positive to negative, but our electron flow is opposite. That's what I have shown here. Electron flow is in opposite direction. Conventional flow is from positive to negative. This whatever I have shown here is the electron flow. And one more thing is, obviously from n layer to p layer electrons are flowing, means obviously our direction should be in this way only, right? So this is how we are going to bias the PN junction diode. In biasing the PN junction diode, while they'll ask you explain PN junction working with a neat diagrams. This is 100% you'll get this question. First question, 100% you'll get for some around six marks. They'll be asking this question. So we are going to classify the working into three types. While explaining, we have to explain in three different stages. First stage is unbiased PN junction. Unbiased PN junction. Second one is forward biased PN junction. Third one is reverse biased PN junction. So unbiased PN junction means how the diode is going to behave before connecting the supply, how it is going to behave. Forward bias means how the diode is going to work after connecting the power supply, that too in positive to the positive and negative to the negative. So how it is going to work. And reverse bias means how the diode is going to work when positive terminal of the diode is connected to the negative terminal of the power supply. See, this is reverse connection only. We have given negative is connected to the positive, positive is connected to the negative. That is, cathode is connected to the positive, anode is connected to the negative. So here you can see that I is 0 amps because under reverse bias condition the diode will not conduct. Why the diode will not conduct, we will understand now in detail. So till here, whatever I have told, all of you have understood? Any doubt in this?
No, sir.
Okay. So coming to the first case, which is forward bias condition. So positive is connected to the positive and negative is connected to the negative. Here, when you are going to connect like this, we have in the book I have given. So we will be showing different the waveforms will be showing like this. This is going to tell about the charge density. Charge density. Can you tell me why this is sine wave? This is a sine wave. Why this is at a lower phase and this is at a higher phase? That means this indicates negative, this indicates positive. Hmm? Why one is positive, other one is shown as negative?
So because they're donating and accepting.
Yeah, that is a positive ion, this is a negative ion. After this, we have one more graph like this. So this is the potential barrier, barrier representation. So in this potential barrier representation, you can see that here this levels as you are going to increase this voltage, as you are going to increase the input voltage, this potential barrier will keep on decreasing. So it will finally it will be like this. This indicates this indicates the voltage which is existing across this. For this electrons, this becomes the positive. There will be a positive potential barrier. For this hole, this will be having a negative potential barrier. Or in other way, we can tell for this electrons to enter to p region, we have a negative potential barrier. For this hole to enter to the n type, there is a positive potential barrier, because you know that whenever you have positive, what happens? Will they attract
Repel,
or
sir.
Repel, sir.
they will repel? So because of the presence of the positive potential barrier across, see, we are going to divide it like this. This is the actual junction. So that junction has expanded on the either side of the p layer and n layer. This is actually the N layer. This is actually the P layer, but the depletion layer has increased. So now this part of the depletion layer will be acting as an opposition to this holes to move towards the N region, because this is having a positive potential barrier, and this region, now this is going to oppose the flow of electrons to the P region, because they are going to act as negative potential barrier. When you have a negative potential barrier, during that time it is going to oppose the flow of charges. So it is going to oppose the flow of charges. But when you are going to apply more power, I mean supply voltage across the supply, then it is going to overcome this barrier potential, and they start moving. So when I keep on when I will be keep on increasing the potential across this supply, what happens? The electron starts penetrating through this, and they start occupying this. And when the electron comes and occupies this, and hole is created here. And again, this electron will shifted here, and that will get shifted here, that will shifted here. Finally, it will come here, and it will reach the battery. Again, next electron will enter. So again, when a hole is present, this will jump here. Again, a hole is created here. This will jump here. This will jump here. This will jump here. Like this, the movement of charges takes place. We have one confusion, usually many of us have. So do we really this particular diode or PN junction, is it producing the charges, or it is just circulating the available charges? Or in any device, will the charge be produced, or it will be just the carriers are just going to keep on circulating?
Carriers will keep circulating, sir.
So that means the carriers are not getting generated.
Yes, sir.
Yes. So everything will be available in the device. So we are just going to circulate the charge. I told you, the goods example, goods and vehicle example. The vehicle is available. So whenever an goods is available, so we are going to fill it to the vehicle, and it will keep on rotating. Here, the electrons and holes are already available, but it needs energy to move. So it needs some energy, then only it can carry that. So that's why we have this potential, the voltage supply, which is going to provide the energy. That energy will be given in the form of charges to these carriers, and these carriers will keep on circulating in the diode. Okay, forward bias, what are the points you need to write? First point is the PN junction diode. P type is connected to the positive terminal of the battery, N type is connected to the negative terminal of the battery. And the input voltage, when it becomes greater than the barrier potential, which is 0.7 for silicon and 0.3 for germanium, then the diode starts conducting. Until the input becomes greater than the barrier potential, the diode will not conduct, and it will not enter into forward bias condition. Once the input voltage becomes greater than the forward bias, or the barrier potential, then the current starts flowing, because the electrons gets attracted towards the P terminal, and the holes get shifted towards the N terminal. So because this process will keep on continuing, such that the electrons flow from N layer to P layer, and the holes get shifted from P layer to N layer, which constitute the current. The conventional direction of the current is from positive terminal of the battery to the negative terminal of the battery, but the electron flow is opposite to the conventional direction. Okay, so this is what we have discussed for the forward bias condition. Next is the reverse bias condition. So unbiased PN junction means you have to explain the one which I explained at the beginning, no, without this part, without connecting anything, how it behaves. How it behaves, it is just going to create some barrier potential. So it will not conduct anything. It is just going to create the barrier potential, and we'll be having a barrier potential of VB, that is 0.7 or 0.3. So after that, you need to explain forward bias, and then it is reverse biased PN junction. Okay. So for today's class, we will stop it at this point.